For nearly half a century, Voyager 1 has been journeying farther than any human-made object in history, quietly slipping beyond the sun's reach and into a region we once believed was largely empty. Built in the 1970s and designed for a mission meant to last only a few years, this fragile machine is still speaking to us after 45 years in space. And what it is telling scientists now is deeply unsettling. Voyager 1 has arrived at a boundary no spacecraft was ever intended to study directly, and the data returning to Earth does not fully match our models, our predictions, or our expectations. Tonight, we're going to uncover what Voyager 1 actually discovered, why scientists are describing it as impossible, and how this single probe is forcing us to rethink the true nature of interstellar space. Voyager 1 is a spacecraft that should have perished decades ago. It was born in the 1970s, an era when computers were primitive, memory was measured in kilobytes, and data was recorded onto 8-track magnetic tape. NASA never imagined this probe would still be functioning 45 years later, let alone transmitting discoveries that challenge modern physics. Voyager 1 was launched to take advantage of a planetary alignment that occurs once every 176 years, allowing it to steal speed from the gravity of giant planets like a stone skipping across invisible hands in space. That gravitational choreography propelled Voyager 1 past Jupiter and Saturn, revealing volcanoes on Io, cracked ice on Europa, and a solar system far more dynamic than anyone anticipated. But once its primary mission was complete, Voyager 1 didn't slow down, didn't stop, and didn't fade into silence. Instead, it kept moving outward, farther than any human creation before it, quietly transforming from a planetary explorer into something far more significant, humanity's first true interstellar scout. For decades, astronomers argued about where the solar system actually ends. The heliosphere, a vast bubble inflated by the solar wind, was supposed to form a clear boundary between the sun's domain and interstellar space. Models predicted a sharp transition, almost like crossing from calm water into a different ocean. Voyager 1 was expected to detect a dramatic shift in magnetic field direction the moment it crossed that line. Instead, something deeply confusing occurred. As Voyager 1 approached the heliopause, it detected an enormous increase in plasma density, nearly 80 times higher than before, a clear signal that it had entered a new region of space. But the magnetic field did not behave as predicted. Its direction remained strangely aligned with the sun's field, even though theory said it should have twisted dramatically. This was not a minor discrepancy. It meant the boundary between our solar system and the galaxy was not a clean edge, but something layered, tangled, and far more complex than anyone had drawn on paper. This is where Voyager 1 made its so-called impossible discovery. The data suggested that the heliopause behaves less like a wall and more like a turbulent shoreline, where solar and interstellar forces mix instead of separating cleanly. Magnetic fields fold into one another. Charged particles swirl unpredictably, instead of stepping into a new environment all at once. Voyager 1 appeared to drift through overlapping regions where solar influence still lingered even as interstellar plasma dominated. This directly contradicted long-standing theoretical models. Scientists had to accept an uncomfortable reality. They had misunderstood the shape and behavior of our solar system's protective bubble. Voyager 1 wasn't just confirming predictions, it was rewriting them. The boundary of our cosmic home was not static, not symmetrical, and not stable. It was alive, dynamic, and shaped by forces far more chaotic than expected. What Voyager 1 revealed has consequences far beyond academic theory. If the heliosphere is porous and turbulent, then our solar system is far more exposed to galactic radiation than previously believed. Voyager 1 showed that cosmic rays from outside the system penetrate deeper and interact more intensely with solar particles than expected. This matters because the heliosphere is the shield that protects every planet, every spacecraft, and every form of life here on Earth from the full violence of the galaxy. Voyager 1's findings suggest that this shield breathes, shifts, and weakens depending on conditions we are only beginning to understand. The discovery forces scientists to rethink long-term space travel, radiation exposure, and even how common life might be elsewhere in the galaxy. Voyager 1 didn't just find something unexpected. It exposed how little we truly knew about the space we thought we understood best. What truly unsettled scientists was not just that Voyager 1 crossed into interstellar space, but that it did so in a way no model had accurately predicted. For years, theoretical simulations described the heliosphere as a relatively smooth, balloon-like structure, expanding and contracting with the sun's activity cycle. According to those models, the heliopause should shift significantly depending on whether the solar wind was strong or weak. Yet, when Voyager 1 reached this boundary, it did so at a distance remarkably close to what Voyager 2 would later measure years afterward, despite completely different solar conditions. This alone shattered the idea that the heliosphere behaves in a simple, rhythmic way. Instead, Voyager 1 revealed a system that resists prediction, where large-scale stability hides intense small-scale chaos, forcing physicists to admit that their understanding of how stars interact with the surrounding galaxy was incomplete. One of the most powerful analogies scientists now use to describe Voyager 1's discovery is that of a shoreline. Instead of a solid wall separating the solar system from interstellar space, the heliopause behaves more like a coast where two oceans meet. Solar particles push outward, interstellar matter pushes inward, and the result is a region of turbulence, mixing, and constant motion. Voyager 1 detected twisted magnetic fields, fluctuating particle densities, and irregular structures that resemble waves crashing and retreating. This means the sun does not simply carve out a clean bubble in the galaxy. It negotiates with its environment continuously. The boundary shifts locally, folds over itself, and creates pockets where solar and interstellar influences coexist. Voyager 1 was not crossing a border. It was navigating a stormy transition zone no one had ever directly measured before. As Voyager 1 moved deeper beyond the heliopause, another disturbing pattern became clear. Galactic cosmic rays increased dramatically, confirming that interstellar space is saturated with high-energy particles capable of penetrating matter and damaging both electronics and biological tissue. Inside the heliosphere, these particles are partially deflected by the sun's magnetic field. Outside, there is no such mercy. Voyager 1's data showed that this radiation environment is not occasional or directional. It is constant. This discovery has enormous implications. It suggests that the galaxy itself is far more hostile than previously assumed, and that planetary systems like ours rely heavily on stellar bubbles for long-term stability. In other words, life-friendly environments may be far rarer, not because planets are uncommon, but because effective cosmic shielding might be. Perhaps the most remarkable part of this story is that Voyager 1 is still teaching us anything at all. Built with technology millions of times weaker than modern devices, operating with fading power and instruments slowly being shut down to conserve energy, the spacecraft continues to deliver discoveries that reshape astrophysics. Researchers analyzing Voyager 1's data today are often younger than the probe itself, using modern tools to reinterpret signals recorded decades after launch. Voyager 1 has effectively become a time capsule that keeps updating itself, bridging generations of scientists and forcing each new wave to confront the same uncomfortable truth. We do not fully understand the space beyond our solar system. And the farther Voyager 1 travels, the more that uncertainty grows. One of the most unexpected realizations to emerge from Voyager 1's data is that the heliosphere is not a neat, symmetrical bubble surrounding the sun. Instead, it appears distorted, stretched, and uneven, shaped by the motion of the sun itself as it travels through the Milky Way. Voyager 1 revealed that the solar system is effectively plowing through interstellar material, creating pressure on one side and turbulence on the other. This explains why the heliopause does not behave uniformly and why its distance remains surprisingly similar over time despite changes in solar activity. The boundary is not breathing in and out as expected. It is being sculpted externally, like a ship's bow cutting through cosmic waters. Voyager 1 showed that our solar system is not stationary or isolated. It is moving through a dynamic galactic environment that constantly reshapes its outer limits. Another deeply puzzling discovery involves magnetic fields. Theory predicted that once Voyager 1 crossed into interstellar space, it should have encountered a magnetic field oriented in a completely different direction from the Sun's. But that did not happen. Instead, Voyager 1 measured magnetic fields that remained strangely aligned with solar magnetic lines. This alignment should not exist if the spacecraft had fully entered a region dominated by galactic forces. Scientists were forced to reconsider how magnetic fields interact at large scales. Rather than snapping abruptly from one domain to another, they appear to drape, bend, and merge in complex ways. Voyager 1 exposed a universe where magnetic boundaries are not clean separations, but overlapping systems influencing each other across enormous distances. Voyager 1's instruments also revealed that interstellar space is not static. Plasma densities fluctuate, particle flows shift, and magnetic turbulence varies, depending on location and time. This contradicts the long-held assumption that the space between stars is relatively uniform. Instead, Voyager 1 showed that the galaxy itself is alive with motion, shaped by ancient supernovae, stellar winds, and shock waves propagating across light years. The region our solar system has entered may be partially ionized, the remnant of violent stellar events long before Earth existed. Voyager 1 is not just measuring empty space. It is sampling the aftermath of cosmic history encoded in particles and fields still moving millions of years later. Perhaps the most humbling lesson from Voyager 1 is that none of this was expected. Every major discovery it made beyond the heliopause forced scientists to revise assumptions that had gone largely unchallenged for decades. Models had been elegant. Predictions had been confident. And yet, reality proved messier. Voyager 1 demonstrated that even our nearest cosmic environment is far more complex than theory suggested. This is why the discovery feels impossible. Not because it breaks the laws of physics, but because it exposes how incomplete our understanding truly was. Voyager 1 did not fail to meet expectations. It shattered them. One of the strangest details revealed by Voyager 1 is related to the termination shock, the region where the solar wind is supposed to slow down abruptly before meeting interstellar space. For years, scientists believed this shock would behave like a clear warning sign, a dramatic slowdown followed by an obvious transition. But Voyager 1 experienced something very different. The slowdown was irregular, delayed, and far less dramatic than expected. Instead of a clean shock wave, the spacecraft detected gradual changes mixed with sudden spikes, as if the boundary itself was unstable. This suggested that the solar wind does not slam into interstellar space like a wall, but bleeds into it through complex interactions. Voyager 1 arrived at a region that theory said should be loud and obvious. Yet reality was subtle, fragmented, and confusing, forcing scientists to rethink how stars lose control over their surrounding space. Voyager 1's measurements also hinted that the interstellar environment surrounding our solar system is not random. The plasma and magnetic conditions suggest that the Sun is currently traveling through a partially ionized region of the galaxy, possibly shaped by ancient supernova explosions. These stellar deaths may have heated and stripped electrons from surrounding atoms millions of years ago, leaving behind a turbulent, energized medium that still carries their signature today. Voyager 1 is effectively flying through the fossil remains of cosmic catastrophes that happened long before Earth formed. This realization adds a chilling layer to its discovery. The space beyond our solar system is not just hostile. It is scarred by events powerful enough to reshape entire regions of the galaxy. Another unexpected finding from Voyager 1 is the strange balance between chaos and stability. On small scales, everything looks turbulent. Magnetic fields twist, plasma density fluctuates, and particle flows change rapidly. But on larger scales, the overall structure appears surprisingly consistent. Voyager 1 showed that while local conditions are messy and unpredictable, the broader galactic environment follows long-term patterns. This duality challenges how scientists model space itself. It suggests that order and chaos coexist naturally, layered on top of each other. Voyager 1 did not just measure space. It revealed how complexity emerges from simplicity across astronomical distances. Perhaps the most ironic part of Voyager 1's story is that it is now making discoveries it was never designed to make. Its instruments were built to study planets, moons, and magnetic fields near the sun, not the structure of interstellar space. And yet, decades later, Voyager 1 has become our most important source of direct data from beyond the heliosphere. Scientists are extracting insights from instruments that were never meant to answer these questions, adapting old technology to explore new frontiers. This highlights a profound truth about exploration. Sometimes the most important discoveries come not from perfect tools, but from perseverance, patience, and a willingness to listen when the universe behaves differently than expected. As Voyager 1 pushed farther into interstellar space, distance itself stopped being just a number and started behaving like a force. Signals weakened to the point where even Earth's largest antennas struggled to separate the spacecraft's whisper from the cosmic noise of the universe. Every bit of data took longer to arrive. Every correction required more anticipation, more patience, and more trust in calculations made hours earlier. This extreme distance exposed a reality most missions never face. Beyond a certain point, control becomes an illusion. Voyager 1 operates largely on its own, following instructions sent long ago, surviving conditions that cannot be adjusted for in real time. The discovery here is subtle but powerful. Interstellar space does not just challenge physics. It challenges the very idea of human control. One of the strangest obstacles Voyager 1 revealed is not radiation or magnetic turbulence, but noise. Space is not silent. It is filled with electromagnetic interference from stars, cosmic particles, and distant energetic events. As Voyager 1 moved deeper into this environment, separating its signal from that background became increasingly difficult. Scientists realized that interstellar space is saturated with information, random, chaotic, and overwhelming. Voyager 1's faint transmissions must fight through that storm to be heard. This changes how we think about deep space communication. The universe is not empty, waiting to receive messages. It is loud, crowded, and indifferent, and only the most persistent signals survive. After 45 years in space, Voyager 1 is no longer just an explorer. It is an aging machine operating far beyond its intended lifespan. Power output drops year by year. Instruments are selectively shut down to conserve energy. Yet, even in this fragile state, Voyager 1 continues to deliver meaningful science. This reveals something unexpected. Longevity itself becomes a form of data. By surviving for decades in interstellar space, Voyager 1 is teaching scientists how materials degrade, how systems fail slowly rather than catastrophically, and how resilience emerges from simplicity. The probe's endurance is not an accident. It is a lesson written over half a century. Perhaps the most profound realization from Voyager 1 is that crossing the heliopause was not an ending. It was a beginning. For years, scientists treated interstellar space as a distant destination, a final milestone. Voyager 1 proved that it is instead a vast, complex environment with its own structure, history, and rules. The spacecraft did not leave the solar system and enter nothingness. It entered another domain entirely, one shaped by ancient stellar events and ongoing galactic processes. This reframes the entire mission. Voyager 1 did not reach the edge of everything. It reached the start of something far larger than we ever imagined. When you step back and look at the full picture, Voyager 1's discovery stops feeling technical and starts feeling existential. After 45 years in space, this small, aging machine has revealed that the boundary of our solar system is not a clean edge, Not a simple line we can cross and move on from, but a living, turbulent region where forces collide, mix, and reshape everything that passes through. The heliosphere is not a perfect shield, and interstellar space is not a quiet void. It is active, aggressive, and shaped by events that happened millions of years before Earth even existed. What makes this discovery feel impossible is not that it breaks the laws of physics, but that it breaks our assumptions. Scientists believe they understood the structure of our cosmic neighborhood. Voyager 1 proved they didn't. Magnetic fields refuse to separate cleanly. Radiation penetrates deeper than expected. Chaos and order coexist in ways our models never predicted. And all of this was uncovered by a probe built with 1970s technology, still operating on fading power, still whispering data across billions of miles. Think about that for a moment. Humanity's most distant messenger is telling us that the universe beyond our sun's protection is far more complex and unforgiving than we imagined. And that exploration beyond this point is not just a matter of distance, but of endurance, protection, and humility. Voyager 1 didn't just travel farther than any spacecraft before it. It forced us to grow up as a spacefaring species, reminding us that the galaxy does not bend to our expectations. If you want to stay ahead of discoveries like this, make sure you're subscribed, because the most important revelations don't come from headlines. They come from quiet data sent across impossible distances. Share your thoughts in the comments, because this discovery raises questions that affect the future of exploration itself. And remember, right now, Voyager 1 is still out there, drifting deeper into the unknown, quietly rewriting what we thought we knew about the edge of our cosmic home. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.